Well, we've been studying sequences, and we've looked at arithmetic sequences and geometric sequences. And with arithmetic sequences, we find a common difference, and we determine what the common difference was, and then we may have found the next 3 or 4 or 5 terms, and then we explored how to find the nth term. And we did the same thing with geometric sequences, but the difference there is a geometric sequence has a common ratio. Rather than a common difference. But now we've proceeded on here to recursive formulas. And so a recursive formula is one in which it allows us to find the nth term of a sequence by performing operations to one or more of the preceding terms. And sometimes we'll find in a recursive formula that it may just be simply an arithmetic sequence, and sometimes it may be a geometric sequence. And sometimes we see both. And in fact, the example that we're going to look at right here actually has both the elements of a geometric and a arithmetic sequence. But let's first read what the problem is. It says, find the first 5 terms of a sequence in which A1 is equal to -2 and AN is equal to -3 times A n minus 1 plus 4. Where n is greater than or equal to 2. And if you look at this and relate it to what we've been doing, well, that right there is a common ratio, -3. But we also see here that we got plus 4 and we got a common difference. And our domain is described as n is greater than or equal to 2. And what is n? N gives us the number of a sequence. And so one of the elements of a recursive formula is we're going to be given A1, and then we're given the formula itself, which we see right here. So we're asked to find the first 5 terms of this sequence. So let's go about this. So then I can say that A2, I'm going to substitute 2 for n, is equal to -3 times A second term minus 1. In other words, I'm going back to the first term of the sequence in this case, which is -2 plus 4. Let's see, -3 times -2 is 6 plus 4, and so that equals 10. Then to find the third term of this sequence, I'm going to still have the -3, except this time I'm going to substitute in 10 for an minus 1. And think of an, I'm looking for the third term, so n here would be, let's say, 3 minus 1. So I'm going to put in the second term of the sequence, which I found to be 10 plus 4. Okay, let's solve. So -3 times 10 is -30 plus 4. That's going to give me -26. Then I'm just going to keep doing this until I get through the 5th term. So the 4th term of the sequence is going to be -3 times -26 plus 4. And let's see, -3 times -26, 8, carry a 1. It's going to be 78 plus 4. Well, the 4th term is going to be 82. You can check my math on that, but would appreciate it if you did. And then we're going to find the 5th term of the sequence. Again, we're going to take the common ratio, -3, times 4th term of the sequence, 5 minus 1, a to 5 minus 1, subscript 5 minus 1, 4th term of the sequence, which we found to be 82, plus 4. And let's see, -3, that's going to be -6, -246, plus 4. It's going to give us -242. And so then our first 5 terms of the sequence, we go back and pick up the A1, which was -2, 10, -26, 82, and -242. So we used a recursive formula to find the first 5 terms of a sequence. Hot dog. I wished I had a hot dog.